Hello there, welcome to this session where I'll be teaching you about logarithms. Now, let's go direct to the point. If you are given a number, you are told that the logarithm of x, let me illustrate by lighting. The logarithm, the short form of logarithm is log. The log of x to base y is written as log x to base y. Let's say this is equals to a. Now this implies that this implies y raised to power a is equals to x. That is what logarithm implies, and that is what is implied by that statement. Now we go to types of logarithms. There are two types. There are two main types of logarithm, or we could say three, but the main ones are two. First one, the type of a logarithm is determined by the base. So we have the common log. This is log to base 10. This is usually very common, so you can it's usually written as log of, let's say, x, but the base is 10. This is the most common log used. Then we have the natural log. This is log to base e. Now e is usually read as exponential and is usually equals to 2.7183. that is into 5 significant figures, and you can write it as log to base e of x. This is equivalent of ln. We write it as ln of x. The third type of logarithm are those logs which have other bases apart from 10 and exponential. So those all other logs, they fall under the same type of logarithm. So let's go direct to the rules of logarithm. Laws of logarithm. And to start off, we shall start with the first row. The first row, we can write it as it's usually called because it involves addition and multiplication, so we can call it as addition product row. What does it state? That row states that given let's say log a to base x plus log b to base x, this is the same as log to base x ab. So if you are adding the two logs, that is with a common base, the determining factor here is the two logs must have a common base. Then what you do, you just pick those numbers that you are getting the logs and you multiply them, then the base remains. So we can do an example. Let's say, for example, log to base 2 4 plus log to base 2 8. This is just the same as log to base 2 32. Now to prove this, we know log 4 to base 2 is the same as 2 plus log to base 2 8 is the same as 3, which is 5. Now let's see whether this is 5. Log to base 2, this implies 2 raised to a certain number, let's call it y, is equals to 32, which is 2 raised to power 5. So y is equals to 5. And what is y? Y is log 32 to base 2. Hence we can say that rule is applicable. So we got the second rule of logarithm. It's usually called the subtraction quotient law. So what does it state? It states that let's use those logarithms that we have used in the addition product rule. So it states that log to base x a minus log to base x b is the same as log to base x. Then you find the quotient between a and b. So that's the second rule of logarithm. So we can prove it. We can say, let's say log to base 3 81 minus log to base 3, then we have 27, let's say 9. So this is the same as what? This is the same as log to base 3, then you have 81 over 9, which is log to base 3 9, which is equal to 2. So to prove that, we can come here. So what is log to base 381? Log 81 to base 3, that is the same as is it 4? That's the same as 4. Then we shall have you subtract 2, which you get 2. Hence we can see that rule is correct. We go to the rule number 3. Rule number 3 is a power rule. The power rule. So the power rule states that log with x ac is just the same as a is raised to power c. This is just the same as c log x a. So from this case, there are two scenarios that come up from this, and the two cases are, let's say a. We can say log to base x raised to power y. This is the same as what? This is the same as y log x, and this is just y. We shall find later that this rule about same power, log to the same power. Then we go to number 2. We have another case. We can call it b. We shall have log to base let's say x raised to power c, then x. So this is equal to what? So you want to prove this. So this is the same as, let's so to prove this, you say to see what it will end up giving you, you say, so you say let let r be equals to log base x raised to log x base x raised to power c. So this implies what? This implies that x raised to power c, then this, or you raise it to power r, is equals to x. So what does this imply? This implies that x raised to power c r is equals to x, which implies that cr is equals to 1. And this means that this implies what? This implies that r is equals to 1 over c. But what is r? R is log 2 base x raised to power c x. So we can say that this is equals to 1 over c. So we go to the fourth rule. So for the fourth rule, we can say log to, log to the same base, log to the same base, log to the same base. So that's very simple. It states that log x to base x is always equals to 1. That is very clear because it implies that x raised to 1 is equals to x, and that is very clear and very simple. So we go to rule number 5. Rule number 5 is called the unity law. The unity law. So unity means 1. So the log of any number, the log of 1 to base any number is always equals to 0. So this implies a log of x to 1 is always equals to 0, regardless of the number. However big it is, it will always give you 0. So that is related to indices, because if you raise any number to 0, you always get 1, and they are correlated. We go to rule number 6, which I think will be my last rule in this case. It's change of base law. So change of base, there are some problems you will encounter that will require you to change the bases, and in this case there are 2 methods of changing the base. So one, we have, if we are given a log b is equal to a, so we can change the base in this manner. We can say log to base, we introduce c as the base, a all over log c introduce b, that is equals to that. So we can prove it. We can prove this. So this is how we shall prove it. So we shall say let y be equals to log b a. So this implies what? This implies that b raised to power y is equals to a. So we introduce a log to base c. So log to base c by is equals to log to base c a. So let me do it here. So we shall find that using the power law, we shall say y log cb is the same as log to base ca. So we make y the subject, y is equals to log base ca all over log cb. And what is y? y was log base ba, hence the proof. There is another method that you use to change the base, and it's very simple. So this is b of the choosing base row, and it is that log of log to base b a is equals to 1 over log a b, log b base a. So we can always prove this. We say let d be equals to log b a. So what does this imply? This implies that what? This implies that b raised to power d is equals to a. B raised to power a is equals to a. Then from that point you can see that b, if you find the root the d of b, power d, you get b. Then you must find the root d. What you do on this side, you must do on the other side. So it will be a 1 over d raised to power 1 over d. Then you introduce the log. No, just before you introduce the log. So this is equals to, this is equals to you can introduce the log at this junction. So we shall have log b is equals to we introduce to base b to base a. Let's say introduce to base a. Log to base b is equals to log to base a power d. Then at this junction, this ad will come the other side. So we shall have 1 over d log a to base a is equals to log a log b base a. So this is equals to, this will be equals to 1. So we shall have 1 over d is equals to log a over b, which implies that d is equals to 1 over log a to base b. But what is d? D is log b is log to base b a, and hence the proof. So this session will end there. I hope you have been able to learn about logarithm. You have known the types of logarithm. You have known about six rows of logarithm, and you can keep in touch. More videos will come, and you can always ask questions in the comment section. Have a nice day.